In the last video, we talked about the constituents of atoms. In this video, we are going to be providing the electronic structure of an atom. Remember that when we drew a structure of an atom, we said that an atom consists of a central nucleus with the proton situated within the nucleus, that is the positively charged particles, and this make up what we call nuclear charge. And we said that electrons revolves around the shell. So if this is like a structure of an atom with electron revolving around the shell, then it means that in providing electronic structure, we have to give this information. We have to tell the atoms of the elements, that is the name of the elements. Then you give the atomic number. Then you give the relative atomic mass. You provide the number of the protons present in the atom. You provide the number of electrons present in the atom, and then provide the number of neutrons present in the atom, and write the electronic configuration of the atom. This constitutes what we call electronic structure of an atom. Before we start, there is something I want us to look at. Remember, we will be dealing at this level now, we will be dealing with mostly the first 20 elements, in which we'll be explaining mostly the s and the p words orbitals, because the first 20 elements were within the s and p orbitals. Remember that our s orbital can only accommodate 2 electrons, while p orbitals can accommodate 6 electrons. Remember that we have px, py, and what? Pz. Of the electronic configuration of the hydrogen is 1s to the power 1. Remember that s orbital accommodates only the maximum of 2 electrons. If the 2 electrons, if the orbital gets filled up, we move to the next orbital. The first s accommodates maximum of, every s orbitals have accommodates maximum of 2 electrons, and there is only 1 electron at the hydrogen, so we get it filled. So its configuration, electronic configuration, is what? Then let's look at helium. Helium has the mass number of 4, atomic number of 2. The proton number, which is equal to atomic number, is 2. The neutron number is the mass number minus the atomic number. That will give us what? 2, because 4 minus 2 is equal to 2. Then the electron number is the number of electrons in the shell. It has 2 electrons. And remember that the number of electrons equal to the number of a proton. Electron is negatively charged, proton is positively charged, so that they will nullify themselves. So in that case now, the number of electrons should be what? 2, because proton number is 2. Then the electronic configuration is what? 1s to power 2, because we have 2 electrons there. So let's fill the column for helium. Helium, we have He is equal to what? The atomic number is 2, the mass number is 4, proton number is 2, neutron number is 2, electron number is 2. Electronic configuration is that. Okay. For lithium, the mass number is 7. The atomic number is 3. 7 minus 3 gives us the neutron number. So 7 minus 3 is 4. So the number of neutron is 4. The proton number is 3. The number of electron is 3, because the number of electrons must be equal to the number of protons. Since proton is 3, it means number of electron is 3. Then the configuration is 1s squared 2s to power 1. Remember, we have 3 electrons. 1, 2, 3. 2 plus 1 gives you 3. So let's fill the column for lithium. We have, being the third element, its atomic number is 3. Then the mass number is 7. Proton number is what? 3. Neutron number is 4. Electron number is 3. Then configuration is 1s to power 2, 2s to power 1. Okay. Remember that the first shell, that is the K shell, accommodates maximum of what? 2 electrons. And every other shell, apart from that K shell, accommodates maximum of 8 electrons. Now, let's provide an electronic structure of an element like sodium. Sodium is this 11th element. That is, the atomic number is 11. So let's go. We have, this is the first shell: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. You can see how I was filling the shells. The first shell has 2 electrons. The next, every other shells will now accommodate 8 electrons. It's only the first shell that accommodates maximum of 2. Okay, now let's write the electronic structure of the sodium. Being the 11th element, it means that the atomic number of sodium is what? 11. Now the symbol is what? Na. That is the sodium element. Sodium, an atom of what? Sodium. Then the atomic mass of sodium is 23. How will we know? We get the atomic mass by adding the proton number to the neutron number. The neutron number of sodium is 12. The number of neutrons present in sodium is what? 12. So 12 plus 11 will give you 23. Since the number of electrons in the shell is 11, it means the number of electrons is what? 11. And since proton number is equal to electron number, it means that the proton number is what? 11. Okay? And knowing that the mass number has been given is in a literature. So since the mass number is 23, take away the number of electrons from it. The remaining will give you the neutron number. So 23 minus 11 will give us 12. So it means that the neutron number is 12. Then let's write the electronic configuration. The first shell has only one s orbital. So we have one s. And that one s, we have 1, 2 electrons that fills it. Then the first shell is filled up. The first s orbital is filled up. We move to the second s orbital, 2s. Remember, we said s accommodates maximum of 2 electrons. So we fill the second s with these 2 electrons. Then we go to 2p orbital. P accommodates maximum of 6 electrons. So we fill 1, 2, 3, 4, 5, 6. We use it to fill the p orbital. So the second shells are now completely filled up. We go to the third shell. And when we go to the third shell, we start from the s orbital. We have 3s. How many electrons is remaining? It's only 1 electron that is remaining. Then you fill it there. So you can see, if we add up the electrons, we have 2 plus 2 plus 6 plus 1. Now we give us 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 1 is 11, which makes up the number of electrons present. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hope is understandable. Okay, let's do for sulfur. Sulfur is the 16th element. So it means we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. Okay, then we have S to be sulfur. Atomic number is 16. The mass number is 32. Then the proton number, since the atomic number is 16, the proton number is the same thing as atomic number, which is 16. The number of electron there is what? 16. Then 16 plus 16 gives us what? 32. Remember we said that the number of mass number is equal to proton number plus neutron number. Since proton number is 32 and is 16, take away the 32. Take away 16 from 32 to get neutron number. It means 32 minus 16 will give us what? 16. So the neutron number is also what? 16. Now let's write the electronic configuration. We start with s orbital. We have 1s, 2, 2s, 2, 2p, 6. Then we enter 3, 3s, 2, 3p. Let's check what we have filled to know what is remaining. The total number of electrons in the shell is 16. And we have filled 2 plus 2, 4, plus 6, 10, then plus 2, 11, plus 2, 12. That means 16 minus 12 is 4. Is remaining 4 electrons. So our 3p will be filled with what? 4 electrons. So this is the electronic configuration of sulfur. Then do that of the chlorine and calcium.